Well, hello, Math 8, and welcome to the video lesson here for Unit 5B, Linear and Nonlinear Functions. We're going to start off here with Lesson 1, which is linear or nonlinear. So we're going to do that here today on this Friday. And we'll have a few slides. I don't think it'll be too bad. You will want to take notes, especially some of these tables that we have some really helpful information that I want you guys to write down. So let's start with this. Basically, it will be one of two slides here. You'll really want to make sure you write down the information. So first of all, linear functions, that's what we're talking about, right? So linear functions would be a function whose graph is a non-vertical straight line. So we actually did a lot with linear functions, if you remember, back before the holidays. We had where we would do slope and y-intercept, so hence our slope-intercept form. So slope-intercept form of equation would be a great example of something that is a linear function. If you graph it, it's a straight line. That's why we would use the straight edges and pass those out and do all that kind of thing, if you remember. And the idea there with the straight line is that the slope is constant. Like no matter where you're at on the line, it's always, rising and running. Rise over run is the slope. It's always rising and running the same amount at each point along the line. So it just stays constant. It's really predictable. It just kind of stays that same pattern over and over and over again. So that's to be contrasted here with the nonlinear function, which would be a function whose graph is not a straight line. And so meaning it does not have a constant rate of change or slope. So it could be kind of really steep in one part of the graph, and then maybe really kind of not that steep, pretty flat, just a very slight incline maybe in a different part of the graph. And so we'll see maybe some examples of that. You also might have remembered some examples actually of some nonlinear functions we actually played around a little bit with, where that was the day before winter break. If you remember, we did that like Desmos activity, and we did some work here with quadratic functions, meaning they had like an x squared in there, or cubic functions, or x to the third. And we're going to do some more kind of with that here. We just have like a really short unit, just a couple of lessons on some of this stuff. But we're going to see some more of those quadratic and cubic functions. But the big thing to know today is those are not linear, right? They're not going to be just a straight line. There's a bunch of curved stuff going on with those graphs that are definitely not lines. All right, this is the other thing you're going to want to write down. And this is what's going to be really helpful today as we talk about linear or nonlinear. That's going to be the big question you're going to have to answer with the Math Excel here. So it's linear, first of all, if, as we said, the graph is a straight line. Okay, so if it's a straight line, we know it's linear. If that's, of course, if you're looking at the graph, like the picture, a table, let's say we've got like an XY table here, there you're looking for a constant rate of change or the same slope over and over and over again. You should see that, you should be able to tell the pattern, and it should be the same pattern from point to point to point. And then lastly, if you just get the equation, it can be written in the form, once again, our slope-intercept form, in case you thought it was going away, y equals mx plus b, right? If you can write it as y equals and you just have a single x to the first, maybe a plus b or whatever, then it's going to be linear. But notice that's only if the highest exponent is 1. As soon as you get like an x squared or an x cubed, the deal's off as far as linear goes. Now, nonlinear, of course, would be the opposite of these situations. The graph, if you're looking at the visual picture, there's not a straight line. The table, if you're looking at the XY table, there's not a constant rate of change or slope as you're going across, so the pattern changes maybe every time. And then lastly, the equation, it can't be written in the form y equals mx plus b, most likely probably meaning that you have an x squared or an x cubed. But there could be some other things. Maybe x and y are multiplied or divided together. If you have like an x over y, or like an x, y squared like together or something, like multiplied together. Those are some issues, right? So you can't have things like that. And then actually the one other case they mention here is that you can't divide by x too. So if you have like 5 over x somewhere in the equation, immediately you know, okay, that's going to be nonlinear right there. All right, so we're going to take an example basically or two of each of these. We're going to look at one that's a graph, one that's a table or two, and then an equation or two. All right, so let's look at, I guess we're going to start with the tables, then we'll get to the graphs here in a second. So the table we'll start with here would be linear or nonlinear. We got x, y, t-chart here. If you notice, the x's go up 2, they go up 2, and they go up 2 again to go from 2 to 4 to 6 to 8. Now, let's look at the y's, and we want to see, it's not that they have to go up by 2, but it has to do the same amount every time, kind of like the x's did. So here, 2 to go to 20, if you do 20 minus 2, that's a difference of 18. So we need to see 18 again if it's going to be linear. Now, the second one looks like it's 34, and the next one looks like it's, 50? So you can see we've got all sorts of different changes happening there. So we're going to have to say nonlinear on this one. All right, the second table, notice the x goes up by 2 again. 2, 2, 2, the same change every time. Now, the y, let's look at that, goes up by 4. Goes up by 4, goes up by 4. Notice we have the same change, consistent just like the x's were. So the rate of change is constant. And so in that case here we would say linear. All right, let's look at a couple examples of the graphs. So the graphs, once again, we're looking for, is it a straight line? So the first one I would say is linear because we have a nice straight line going across the graph. Whereas the second one, notice how it kind of goes this way and then it curves upwards. So that fact that it curved and it changes, you know, it would be pretty steep right up there at the top. It's pretty flat kind of around there. So definitely a big difference there in what the slope is at different points. So that's a good example of something that's nonlinear. All right, we'll finish here with looking at the equations. So once again, as soon as you see something that would be like an x squared, you know right away nonlinear, because we have to have it, once again, to be linear, it's got to be y equals mx to the first, only to the first power, plus b. So the second one, I see that it's 5x to the first, but let's see if we can rearrange it into our slope-intercept, and that'll kind of tell us here for sure if we can write it in that y equals mx plus b. So let's do that. Let's add 4 here to both sides to move that over. I get y equals 5x plus 4, and definitely looks like it matches that y equals mx plus b form there. So we could say linear for that one. And that concludes our video lesson here for today.